A pleasant day to all of you. Let me introduce first. My name is Ellen Joyce L. Austria, taking a course of Bachelor of Elementary Education, Generalist. For today's discussion, the main topic will be induction. On completing this video, you should be able to state the principle of mathematical induction, define and understand the concept of induction, prove valid formulas for all n element of natural numbers by using the principle of mathematical induction. Also apply the concept of induction in testing equations truthfulness. In this video discussion, we will tackle induction, as I have said earlier, followed by false proofs. Then we will focus on mathematical induction and simple examples. Before we proceed to proving by mathematical induction with additional conditions and requirements which we call harder proofs. Then, let's proceed to induction. Induction, it is a type of reasoning in which you utilize particular ideas or facts to develop an overall rule or conclusion. Inductive reasoning begins with specific and narrow observations and progress to a reasonable generalized conclusion. Inductive reasoning is a technique for arriving at conclusions by moving from the specific to the general. It is used to establish a causal relationship between a premise and hypothesis. A conclusion you reach using inductive reasoning is called a conjecture. Let's proceed to the example. Example number 1. I have seen 4 students at this school leave trash on the floor. The students in this school are disrespectful. The first sentence of the statement, I have seen 4 students at this school leave trash on the floor. It gives a teaser or a primary idea that led to concluding that students in that particular school are disrespectful. In induction, details come first before the conclusion. And then, now the next example will be number 2. Mark likes math. Today's lesson is about division. Mark will like today's lesson. The first 2 sentences, Mark likes math. And today's lesson is about this division. It validates the conclusion that Mark will be going to the discussion for that day. Again, details come first before the conclusion or the conjecture compared to deduction. Deduction is idea first, followed by observations and a conclusion. Always remember that induction is observation first, followed by an idea that could explain or statement that concludes or generalize the whole concept. Now, let's proceed to the false proof. False proof is not the same as a false belief. One can read faulty proof, be confident that the conclusion is incorrect, and still have difficulty identifying the error. The following are some examples of incorrect induction proofs that show false proofs and what may happen when tiny details are overlooked. Just for example, number 1, the chair in the living room is red. The chair in the dining room is red. The chair in the bedroom is red. All the chairs in the house are blue. As you can see, the statement is untruthful because that details don't support the conjecture. because tanawa diri ana siya, the chair in the dining room is red. The chair in the bedroom is also red. And the conclusion, the chair in the house are blue. Nganong na blue naman na red ng tanan kaha. So, the statement is untruthful. There are red chairs already in the living room, the same as the bedroom, so it does not make sense to say that all chairs inside the house are blue. That makes the statement itself incorrect. Okay, let's proceed to the next example, the number 2. Prove 2 plus 4 plus 6 plus 8 plus ... which is the ellipsis, plus 2n equals n raised to. In mathematical induction, the first thing to do is always try the first one. If it shows untrue for the first one, that means the statement itself does not show true for all natural numbers. So, these are the example. So, test n equals 1. Test n equals 1 here, since 2 is not equal to 1 raised to, thus it is not true for n equals 1. Hence, the equation that the 2 plus 4 plus 6 plus 8 plus ... which is the ellipsis, plus 2n equals n raised to is untrue. Now, let's proceed to the mathematical induction. What is mathematical induction? It is a method for proving natural number conclusions or establishing claims. It shows truthfulness, noted truthfulness of a statement or a formula or a theorem for all natural numbers. There is a property of natural numbers called well-ordering. It says that any non-empty subset of n has the smallest element. We can use this to prove induction. That makes mathematical induction a valid proof. Mathematical induction is a unique way of proving things. It consists of 2 steps. Always remember that first one, show true for the first one. The second is show that if anyone is true, the next one is also true. Again, noted, if you shows not true in the first one, it is automatically na false proof siya. And if it shows na true siya, then automatically ang sunod jud is true sad. Then let's proceed to the example of mathematical induction. Number 1 is 3 raised n minus 1, a multiple of 2. Test for n is equal to 1. Then, ibaba nato. Simplify. 3 raised 1 minus 1 equals 3 minus 1 equals 2. Baba lang. Then, 2 is a multiple of 2. So, true for n equals 1. Diri, let's assume that, for example, let's assume true for n equals k. So, 3k minus 1 is equals to 2p. So, prove true for n equals k plus 1 and k raised k plus 1 minus 1 equals 2q. 3 quantity of 3k minus 1 equals 2q. 2 quantity of 3k plus 3k minus 1 equals 2q. 2 quantity of 3k plus 2p equals 2q. So, 2 quantity of 3 raised k plus p is equals to 2q. So, the statement 3n minus 1 multiple of 2 is proven true for all natural numbers of n. Next will be the number 2. Example number 2. 1 plus 3 plus 5 plus dot 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 plus the quantity of 2n minus 1 equals 2 squared. Test for n equals to 1. Let's assume that true for n equals to k. Here, simplify 1 plus 3 plus 5 plus dot 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 plus quantity of 2k minus 1 equals k squared. Proven true for n equals k plus 1. And solution will be 1 plus 3 plus 5 plus dot 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 plus quantity of 2k minus 1 plus the quantity of 2k plus 1 minus 1 equals k plus 1 squared. K squared plus the quantity of 2k plus 1 minus 1 equals the quantity of k plus 1 squared. K squared plus 2k plus 2 minus 1 equals, bring down the k plus 1 squared. K squared plus 2k plus 1 equals, bring down again k plus 1 squared. Factorize k plus 1 squared equals k plus 1 squared. The statement 1 plus 3 plus 5 plus dot 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 plus the quantity of 2n minus 1 equals n squared is proven true for all natural numbers of n. Next, let's proceed to the example number 3. 5 plus 9 plus 13 plus dot 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 plus quantity of 4n plus 1 is equals to n, the quantity of 2n plus 3. Test n equals 1. For the quantity of 1 plus 1 is equals to 1 times 2, the quantity of 1 plus 3. 4 plus 1 is equals to 1, quantity of 5. So, 5 is equals to 5. It is true for n equals 1. Let's assume that true n is equals to 1. So, again, 5 plus 9 plus 13 plus dot 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 plus 4k plus 1 is equals to k, the quantity of 2k plus 3. Then, let's prove true for n equals to k plus 1. 5 plus 9 plus 13 plus dot 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 plus quantity of 4k plus 1 plus 4 quantity of k plus 1 plus 1 is equals to k plus 1 times 2, the quantity of k plus 1 plus 3. So, k, the quantity of 2k plus 3 is plus 3 plus 4k plus 4 plus 1 is equals to the quantity of k plus 1 and the quantity of 2k plus 2 plus 3. And then k, quantity of 2k plus 3 plus quantity of 4k plus 5. Gi-plus ni mo siya sa taas. And then equals to k plus 1 and 2k plus 5. And then reciprocal, 2k squared plus 3k plus 4k plus 5 equals k plus 1, quantity of 2k plus 5. 2k squared plus 7k plus 5 equals k plus 1, quantity of 2k plus 5, and then k plus 1, quantity of 2k plus 5 equals to k plus 1, quantity of 2k plus 5. So, diri na ta. The statement of 5 plus 9 plus 13 plus dot 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 quantity of 4n plus 1 equal n, the quantity of 2n plus 3, is proven true for all natural numbers of n. Example number 4. 2 raised 3 plus 4 raised 3 plus 6 raised 3 plus dot 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 plus the quantity of 2n raised 3 equals 2n squared, quantity of 2n plus squared. 2 quantity of 1 raised 3 equals 2 quantity of 1 squared, quantity of 1 plus 1 squared. 2 raised 3 equals 2 the quantity of 4. So 8 is equals to 8. It is true for n is equals to 1. Let's assume true for n equals to k. So again, 2 raised 3 plus 4 raised 3 plus 6 raised 3 plus dot 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 plus the quantity of 2k raised 3 is equals to 2k squared, 2k squared, quantity of k plus 1 squared. And then let's prove true for n is equals to k plus 1. Solution will be again 2 raised 3 plus 4 raised 3 plus 6 raised 3 plus dot 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 plus 2k raised 3 plus quantity of 2k plus 1 raised 3 is equals to 2k plus 1 squared, quantity of k plus 1 plus 1 squared. 2k squared, quantity of k plus 1 squared plus 2 plus 1 raised 3 is equals to 2 quantity of k plus 1 squared, k plus 2 squared also. Next will be 2k squared, quantity of k plus 1 squared plus 2 raised 3 k plus 1 raised 3 is equals to 2 quantity of k plus 1 squared and k plus 2 squared. Then k 2k plus 1 squared, quantity of k squared plus 2 squared, quantity of k plus 1 is equals to 2 quantity of k plus 1 squared and k plus 2 squared. Then k quantity of 2k plus squared, quantity of k squared plus 4k plus 4 is equals to 2 quantity of k plus 2 squared plus 1 squared. Rationalize lang nimo siya, and then the statement of 2 raised 3 plus 4 raised 3 plus 6 raised 3 plus dot 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 plus quantity of 2n raised 3 is equals to 2n squared, quantity of n plus 1 squared is proven true for all natural numbers of n. Okay, let's try for the harder proofs. At this point, the statements, formulas, and theorems that we will prove require are more conditions or specific conditions that may complicate the difficulty. The most common example is demonstrating divisibility using induction. First example number 1, prove that n raised 3 plus 3n squared plus 2n is always divisible by 6. So test for n is equals 1. 1 raised 3 plus 3 quantity of 2 squared plus 2 quantity of 1 is equals to 1 plus 3 plus 2 is equals to 6. So true for n equals 1. Today, let's assume true for n equals 3. Examples such as k raised 3 plus 3k squared plus 2k equals to 6p. Let's use p, where p is the element of z. Prove for n equals k plus 1, such as quantity of k plus 1 raised 3 plus 3 quantity of k plus 1 squared plus 2 quantity of k plus 1 is equals to 6q, where q is the element of z. So LHS equals k raised 3 plus 3 k squared plus 3k plus 1 plus 3k squared plus 6k plus 3 plus 2k plus 2. So, gisimplify lang mo siya. Is equals to 6p plus 3k squared plus 9k plus 6. By assumption, the 6p plus 6 plus quantity of 3k squared plus 9k. So, the 6p plus 6 is already divisible by 6, right? So, the quantity of 3k squared plus 9k is equals to 3k quantity of k plus 3. So, the k quantity of k plus 3 or either of k quantity of k plus 3 is odd or even. Thus, the quantity of k plus 3 is always even. Hence, the LHS 6p plus 6r plus 6 is equal to 6 quantity of p plus r plus 1 is divisible by 6. So, the statement n raised 3 plus 3n squared plus 2n is always divisible by 6. So, it is proven true by the induction. Prove that 3 raised n plus 7 raised n is divisible by 10 for odd n elements of z. Let's assume true for n equals 2k plus 1. 3 raised 2k plus 1 plus 7 raised 2k plus 1 is equals 10p, where k, p elements of z. 3 quantity of 3 2k plus 7 quantity of 7 2k equals 10p. Prove true for n equals 2k plus 3. So, examples such as 3 raised 2k plus 3 and then plus 7 raised 2k plus 3 is equals to 10q. So, i-prove na to na where q elements of z is equals to 9 quantity of 10p plus 40 times 7 raised quantity of 7 raised 2k by assumption. So, it is equals to 10. Then, quantity of 9p plus 4 times 7 quantity of 7 raised 2k. So, 10q since 9p plus 28 quantity 7k raised 2k is the element of z. So, the statement 3 raised n plus 7 is divisible by 10 for odd n elements of z is proven true by induction. So, that's all for our discussion for today, and I hope you learned something from me. Thank you and have a good day.